Following on from a previous post I shared on LinkedIn regarding generating load combinations within Python, I started putting together the final touches on a tool that I've been developing over the last while. Last year at an iStructE event, I showcased this rough proof of concept Jupyter file of this very tool I'm about to showcase now. In essence, it's an interactive engineering loading library, and it's called Thought. So first of all, I suppose, why create this type of software? And it all comes down to the engineer's dilemma with regards to loads. So first off, buildings are complex. The design standards that we have to design these buildings for vary between country to country, between use case, between contents, within the building, etc. The information is not clear as to where the loads come from, the magnitudes of these loads, etc. The sources of information is sometimes forgotten, and it's just passed on colloquially between engineers or between practices, and it's never really questioned. And of course, if it's not really questioned, it's not really verified. And that brings me on to the last point, that not all these loads are verified, and some are often based on engineering judgment. And who's to say that engineering judgment is correct? A much more thorough and accurate approach is to have it tabulated, controlled, regulated, and of course verified by peers. So what is the current solution? What are other engineers using? Well, if you go into any engineering practice, you'll see some sort of Excel table like this or something similar, whereby they have zones, they have different types of loads here. They will have comments for themselves internally. But as you can see, none of these loads are quite verifiable. They're assumed, or they've been passed on from engineer to engineer. That doesn't really work. Some may just use loads directly from design standards like the Eurocodes, for example. However, not all loads are given in the Eurocodes. A typical example is category E2, and it's up to the engineer to determine these loads. So then the question is asked, how can this be done? So if we were to just recap over what we just went through, we can break it down to three main headings: use of Excel, loadings, and quality. In terms of using Excel, there's no real file management system. There's no consistent approach between engineers, within an organization, and between organizations. Revisions to this tabulated data isn't tracked. Calculations there are hard to interpret. And even in certain rows and columns within an Excel sheet can interfere with internal calculations. With regards to loadings then, these loads are usually inherited from engineer to engineer without ever understanding what makes up these loads. A typical example of this is service loading of 0.25 kilopascals. Where did this load even come from? What are its limitations? Is it even a legitimate load these days? Finally, in terms of quality, junior engineers aren't getting a full understanding of where these loads are coming from. This rinsing and repeating of loads from previous projects is washing away lessons learned for the future generation of engineers to come. So then, what's the alternative? Well, I'm proposing a web-based solution, which means that there's no download required. It's going to be continuously updated. Currently there's over 1,500 loads and counting, with approximately 80% of those verified. This includes colloquial loads, which are loads just passed down between my own experience and the experience of colleagues, and of course verified loads with references for individual inspection. These loads can be assigned on a per region basis. These loads are then summed, and of course an export to Excel is possible also. So before we go into actually what the software does, it's important to actually understand a few of the basic principles behind the software. So one of the main and important aspects of this software is load categories. So if you were to look at the likes of the Eurocode, they split loads up into approximately 8 different types of load categories. So you have permanent, services, imposed, wind, snow, thermal, execution, and of course accidental load categories. Action orientation. So not all actions are orientated perpendicular to the surface that they are applied to. Not all software takes this into consideration, and very little information is recorded on this. So if you were to look at this picture over here, you can see that live loads in this instance are applied on a horizontal plane projected vertically, whereas the likes of a wind load is projected perpendicular to the plane that they are applied to. Similarly, dead load such as self-weight and items like that are along the member but in the vertical direction. So it's important to understand that different loads will have these different orientations applied to them, and to the best of my knowledge there's not a software out there that currently takes this into account. So if we were to look at a real example then, so this is a project I was involved in a couple of years ago. So if we were just to look at the roof, you can easily assume that there's going to be a certain amount of permanent actions, services, variable actions, wind, etc. But what does that actually look like for the engineer? The engineer will have to determine what load is due to PV panels, what load is due to the MVHR system, what loads are due to suspended ceilings, battens, roof tiles, roof imposed loads, snow, timber rafters, plywood sheets, vapor control layers, etc. So it is quite complicated. And then of course if you're to look inside the building, it's even more complicated. Different rooms will have different loads, different rooms will have different material builds up, some rooms will have a similar load and similar material build-ups. This is hard to quantify loads for individual rooms. So then what is the process then that the engineer will have to do with this software? Well, it's a 5-step process. So the first process is that we split the project into zones. So we split it into buildings. So buildings 1, building 2, building 3, etc. Within each building, then we split all the rooms or all the elements into regions. So we'll have a ground floor office, we might have a gym, we might have roof. We then assign the loads to these different regions. Okay. We then calculate the loads for these regions. We then sum them up, we export them out into Excel, and then we can apply them to the structure. Okay. So here we will demonstrate the live demo. So as you can see, there's a login and a password section. I'll just skip ahead to where I'm actually putting the password. So here I put in my login username and I put in the password, and then it'll tell me welcome Mervano. So then I know I'm logged in. On the left hand side here we have an option for unverified loads. So unverified loads would be loads that don't have a valid reference. Okay, so they could be loads from say internal references that you might have yourself. There might be client specific loads, etc. So for the purpose of this demo, I'm including them. There's also an option to view the database. So some people might want to see what loads are included, so we give them that option. So here I'm selecting open HTML view. I click apply here, and what that'll do is that'll actually generate a table with all these categories applied to it. Now, if I didn't want to see all those categories, I can untick some of those blue ticks, click apply, and that'll reduce the number of columns that's visible. As you can see, all these loads have black dots associated with them. The black dot means that I have a load to be associated with that load type. You'll also notice that there's a green verified tick mark beside them, so that'll tell you that it's verified. And of course there's a reference value to the left of these green ticks. Up at the top I can also filter, so I can filter by area, or I can filter by roof type or building type, etc. So if we were to look at how the software works, we apply a zone. So this zone is going to be building 1. Within that zone then we apply different regions. So for this example I'm only going to apply 2 regions, so gym and roof. Once I'm satisfied that I have enough regions, I then click next. And then for each zone and for each region within each zone, this option will come up. So I can assign loads based on a text file or an interactive table. Okay, so what I'm going to do here is, for the gym floor I'm going to upload a text file, and for the roof I'm going to use the interactive table. So basically the benefit of using a text file is that if I have similar loads for similar zones, I don't need to keep selecting the same loads every time, whether it's for this project or for a different project. I can export my selection and then I can re-import it on different jobs. So I've uploaded the file, I can see what its contents are, and then I can just assign that file to that region. Okay. Now if I wanted to add even more loads after the fact, I can. So if we were to look at the roof, then we'll click on the interactive table. We can search for different loads, we can filter for different loads, and of course we can just select the various loads. So we can actually manually just scroll down and pick what we want, or we can use the search bars up on top to search for particular different types of loads. You'll notice that not all of these loads have their values shown. So for example, some of those loads will have grayed cells. The grayed cells means that its value is determined based on a calculation. Okay, so once the selection has been saved, you can see a summary basically of the loads that have been selected. Of course, the option there then is to export those loads into a text file for subsequent use. Okay. Again, you can see that some loads have been verified, others haven't. I click on next. And then for all the loads that require calculation, these will come up in this next section. So of course there's going to be default values that are shown there, but I can easily input any value I wanted. Once I am happy that all loads have been included, I can hit submit assignments. And a green pop-up will tell me that they have been updated. And as you can see, the calculated values are now shown underneath. Moving on to the next zone and the next region. As you can see, it's just as simple as that. I can just put in whatever value I feel or the engineer feels is required, and straight off the bat the loads are calculated. Once I'm happy with that, I can click on next, and then down below is a review and exports table. So basically all loads are then summed in terms of their type, which is whether they're applied on an area or a point load, and they're summed based on their direction. So horizontal loads won't be summed with vertical loads, they'll be split. Okay. So once I am happy with all of those, I can then click on the little Build Excel button, and up at the top you can see that there's an Excel file being generated, and then I can just simply download that Excel file to use elsewhere. And as you can see, that's the Excel file developed there. So it's all the loads that we've previously gone through. And from here then the engineer can apply it and put it into their document. They can use it in different design softwares, etc. So some of you might be saying, what we have already works. Many engineers are stuck with this kind of mindset that if it's not broke, don't fix it. Many engineers, in my opinion, are set in their ways. Henry Ford once said, if I'd asked people what they wanted, they would have said faster horses. And if you use the same tools as your competitor, then how can you gain that competitive edge over your competitor? This often requires change. So whether you want to gain confidence in your loads assumed, whether it's to provide a learning tool for your graduate engineers, or whether you want to use the exact loads to reduce loads on a structure, to reduce carbon footprints, to reduce costs, or even if it's just to assess the capacity of existing structures against the loads that they are actually expected to withstand, then perhaps maybe this tool is for you.